All right, so number 9. When you see one like this, it kind of looks like a quadratic you could factor. See how it has like that 2 to 1 ratio here of 4 and 2? And if you think about a quadratic, quadratics are always like, x squared plus or minus some x term, plus some constant term. But it's always got that 2 to 1 ratio here with the x squared term and the x term in the middle. That's what you have here, like 4 and 2 is like 2 and 1. So what you want to use here is something that, and you'll see this a lot in calculus, and it has different uses there, but it's a similar idea. And some people call it the U substitution, and we'll just, instead of using U, I don't really like writing my U's because I don't know, but I'll use an N. So I'm going to call it N substitution, but you can call it, you'll see it maybe called U substitution in calculus. So I'm going to take an N and I'm going to say N equals x squared. I'm just like declaring that. I'm setting N equal to x squared. So what I'm going to do now with this is go back to my quadratic and substitute N in for x squared. So I still have the 36 because there's no x. Minus 13. X squared is n, so I'm going to make the x squared an n. And then x to the 4th power, if n is equal to x squared, n squared is going to be equal to x to the 4th, right? This is like 2 of these. So now that we have this here, we can factor it. So what multiplies to 36 that adds up to 13? It would be 9 and 4, right? So we're going to say n minus 9, n minus 4, because this is a negative. So now that we got it factored there from this, we want to go back in and put our x squareds back. So I'm going to say x squared minus 9, x squared minus 4. And then from these two, now you're at just like solve by square root time from these two binomials. This is a great spot. It's much easier when you can get here because all you need to do, I'm just going to set this equal to 0, move the 9 over, x squared equals 9, square root both sides, and I get x equals plus or minus 3. This one, same thing, x squared minus 4 equals 0, x squared equals 4, square root both sides, x equals plus or minus 2. Now there are 4 solutions. On this one you could have just put in the calculator and you would have seen all 4 of those. But you could just as easily have one like this where you can't see any roots. They might all be imaginary. And instead of this being, if this was a plus 13 instead of a minus, this would have been a plus, this would have been a plus, and these all would have been an imaginary roots. This way, it works out nicely where you get the integer roots, but it could have just as easily, if that had been a plus, it still would have factored, but this would have been a plus and a plus, and then this would have been a minus and a minus here, making these imaginary. So even though we could have done this by graphing, it's good to kind of just see how you could do it by factoring, because sometimes graphing won't work and this is the only thing that'll work.